Well, good morning. I want to go over these station numbers. I had a discussion yesterday with one of my students. I felt like I clarified it, and I think he felt like he understood it. But the more I look at it, I think the more we need to talk about it. It's one of those things that I taught this class last, uh, uh, back in January, and I don't think we went through this. If we did, we didn't go enough because some of this material comes from that class. So you're looking at your screen there. This is as you can see up here, it's quite an extensive manual. It's got 256 pages, and it's all about grade setting. It's put out by the what is it? Operating Engineers Union, and I like it. It's simple. It's old school, but you know, nothing has changed since the pyramids. The principles remain the same all the way up to and including the automated grade control that you see so widely used today. All of that stuff, the digital terrain models are still based on these same principles. So it's important that we get a good grasp of these very fundamental uh, foundations of how to set grade or how grade is set. So there's just a little excerpt with the test that I threw in there, and I don't believe the test is accurate, and some of you have struggled wildly with that, but I'm going to use that as a teaching mechanism and go over that test with you and reopen that test, and you have a couple of days from today to go back in and retake the test, having seen, having been given the information you probably really need to pass that test. Uh, so let's just begin with uh, a little bit about stakes, a very little bit about relative to how many they are. But at the top, it's talking about survey and construction stakes are made of wood and generally of three types. There are marker stakes, there are hubs, and lath, as illustrated in Figure 32, which is here. And they got names for these things, and I can't quite make that out. This is 12 inches long, and I'm not sure what that is. But this is called a marker stake. It could be used for a lot of things. It could actually be used to put information on it. But I think the primary use for what we would call a marker stake, uh, it would have maybe locations of points and but not precision points. Maybe not to the property lines, right away. Even I call it not precision. Precision points are put on hubs. That's this one right here. So let's just read what it says up here. Again, this is a lath. It's really thin. It's only about a 3/16, I think, or up to maybe a half-inch thick. So they're pretty flexible. And actually, the art of driving one in the ground, uh, and you can see they're 3 foot to 4 foot, is uh, is something you have to get used to. So let's. I left something. Survey stakes are identified are primary identification states containing explanatory data. This is like opening when you buy a new grill and you open your set of instructions on how to put it together. That's what a survey stake is, and primarily we'll get into more complicated ones as time goes by. Survey stakes usually accompany hubs. There's usually the stake, a lath, and then in front of it is the hub. The hub is the actual reference point both for horizontal and for vertical measurements. In the center of the hub is it's called a survey tack. It's a tack, kind of a little hollow tack. Uh, so survey stakes are primarily identification stakes containing explanatory data. Survey stakes usually accompany hubs and mark the type of hub and its horizontal and vertical locations relative to the job site or to the top of the hub. Marker stakes are also used to mark the center line. They're a little bit thicker, probably 2 by 1.5, something like that, to mark the center line, right-of-way lines, offset, and sometimes cut and field data, and many other purposes. But written on them will be what they represent, maybe even an elevation above sea level. And actually, I found that I don't think we've talked about where all these elevations come from. Uh, Benchmarks, I think you guys were exposed to in the let me know if you weren't exposed to in the certificate program. Benchmarks are medallions, if you will, and they're put out by survey companies. I think also uh, they're put out by the USGS, United States Geological Survey Administration. But that all comes under the, I think, National Oceanic Atmospheric Association. Regardless, when a survey company puts out a survey stake, it becomes permanent. Puts out a benchmark, I'm sorry, it becomes permanent. So lath, on the other hand, is very temporary. These right here are very temporary as far as you don't set them up and take them down, set them up and take them down, but they're not going to be there uh, perhaps very long. They may change, get knocked over, get replaced, but they're just telling you the information concerning these hubs. Or in the early classes we had, we put a crow's foot down here to serve the purpose of a lath. So it's very temporary. Individual pointed laths are driven into the ground, and they're marked and may carry the grade line marked directly on them. I know we looked at some that had a line that had a crow's foot on it to indicate grade. We had a line telling you the reference point for a cut or a fill on some of the early in basic stake marking. Uh, let's see, carry the grade and directly on them are figures denoting the height of the cut or fill to be accomplished at that point. They're often marked with flagging ribbon for easy vision. Uh, they're usually pink. Pink is a color code for temporary survey stake. They're not so likely to be buried or hidden by earth as a hub may be. So if it's got a lath beside it with a cut on it, you'll know somewhere down here, maybe drove into the ground and it got dirt pushed up over it, there's a hub. They often mark with flagging ribbon for easy vision. Their main advantage is that their height. They're not so likely to be buried or hidden by earth, windrows coming off the blade, and spillage from machinery, like a loader or something. Lath is particularly useful in grading operations. Actually, very useful. A lath is your set of directions. Let's see what else we got here. Here's what started it all. Stations. I take for granted stations that they can be complicated. And we'll just go ahead and talk about them real quick. Uh, First, let's talk about line. Line is the path that any features of a project takes along the route of the project. Three common lines that a grade checker encounters are a center line, something going down the center of a road, a property line, you know, and right away, same thing, and a flow line would be the inside bottom of a pipe if it was carrying like sewer or water. The inside bottom of that pipe would be considered the flow line. But it's talking about, here we go, stations are a series of points set 100 feet apart, horizontal measurement to locate and describe a line survey, like down the center of a road, starting at 0 and then going down at 100 feet. You put 1 plus 0, that's 100 feet. Another 100 feet, you put 2 plus 0. I'll say this again, but anything on the left of the plus sign, and when I say left, is if you're looking at it, would be 2, like here, that's 200. That's 100, and that's 0. Anything on the plus is in addition to. This may be 1 plus 55. That would be 155 feet instead of just 100. So going back up here, stations are marked on stakes as follows. 100 feet is written as 1 plus 0, 0. 200 feet is written 2 plus 0, 0, and so on. This holds true for indefinite lengths such as 38,000 feet, really, which would be the same as 360 hundreds plus 0, 0. See, here's 100 plus 0, 0. This is 360 hundreds. So that's this 300, supposed to be 380. 380. As you see here, that's 38,000 feet. There's 380 hundreds and nothing else. So this stake is 3,800 feet. You just ignore that. I'm sorry, 38,000 feet from the beginning of the project. You can ignore that plus sign to get this. Are 3,800 stations, given the stations are 100 foot apart, or whatever the length of project is. The starting point of a survey is called the starting station, and is numbered 0 plus 0, 0. You hadn't gone. This is the very, very beginning. Projects usually run, I think, west to east and south to north. That's not necessarily the case every time, but I look at it as left to right when they're line projects, when they're horizontal. So, or whatever the length of the project. The starting point is 0 plus 0, 0. The next station is 100 feet further and numbered 1 plus 0, 0. The next station, 2 plus 0, 0 feet beyond the starting point is then and so on. All stations that end with 0, 0 are called full station. In other words, this is a full station because it's 100 feet. If this was 1 plus 50, this would be not, it wouldn't be a full station because it would be 50 feet further down than this 100. It would be 150 feet. Let's see if we find the next station, 200, and then numbered 2 plus 0, 0, etc. All stations that end in 0 are called full stations. Let's see what else we have here. Abbreviation for station is STA. Here's a good look at although it's not a pretty picture, it's very explanatory. This is a highway being built, and as you can see, well, let's see what it says it is before I go claiming that's what it is. Typical highway part. Right here, we're starting at 1, the 2. This is station 1 plus 0, 0, right here. 100 foot down is 2, 0, 0, and then 3, 0, 0, and then 4 plus 0. But look here, the next station is 4 plus 7, 5. So this one, they're getting shorter because they're about to go around a curve. See, this is 4 plus 7, 5. So this stake is 75 feet further than this 400. This right here is 5. There's 25 feet in here going around this curve. So that's 5 plus 0, 0. And this is 550. And here's a number I can't distinguish. That's 25. So it goes on to all the way. I think that's even like 450. So it's taken us all of these stakes to get around this curve. And but they're still based on 100 foot. Some would be 4 plus. This is 5 or 6. I'm saying 4. That's 6, I think. And then here's 7, and then here's 8, and we're getting a straight line. So we're back to where's that? I want to get right here. Full stations. We're back to full stations once we get around that corner. Now, here's that test. And although we're working this as in class, let's say it is a class, you should make a good score on it because I want to talk about it. This is that uh, quiz, week 3 quiz number 2. And I didn't prepare you for it. So here it is. Uh, Established points of known elevations are called, and that was the very first thing we talked about in this video, benchmarks. The reference or 0 point for elevation is, as we said earlier, mean sea level. In other words, tide comes in, tide goes out. The average of that elevation is called 0. And then, like when you go from Galveston, Texas, and you start driving up the road to Houston, your elevation starts rising because you're actually coming above sea level and continuing all the way to the Rocky Mountains where you get to 10,000 feet above sea level. Now, there are exceptions, New Orleans being one. It is mostly, I think, when I say mostly, I'm not sure how much, but it's below sea level. So there are some places where 3 foot of the buildings are 3 foot below sea level, and they have levees or dikes around that cities in different places. But sea level is the 0 point for all elevations. Now, benchmarks are considered permanent. I briefly went through this when they're set by survey company. That's the correct answer for the test. Uh, I'm not so sure that this wouldn't be a good answer to, you know, but this one's going to be the one you want, survey companies. Uh, Precision points, they're the hubs. That's where you'll find that tag. That's right on the money of where you start from. Stakes that contain explanatory data. They're your survey stakes. That's what they're called, survey stakes. That was the second sentence or something that we went through up there. when we first started the video. And to convey a cut or fill information, you would put the information on a lath. Uh, it also said you may use it on a marker stake, but this is where you're going to find it for the most part, on a lath. That's the skinny, uh, 4 foot tall stake we saw back there. And now it's given us a little multiple choice. How do you express 3,125.6 as a station? Well, it's 3,125.6. So it's going to be 31. That's how many hundreds plus 25.6. You see? 3,100. That's how you would change this figure to a survey station number. There'll be another example, I think, too. So this right here, how many feet are there between station 2550 and station 3675? In these cases, you can just ignore the plus sign and get your calculator out. There's mine. And take the station number, how many feet are there between station 2550, 3675? 3, and do it like this: 3675 minus 2550 equals 1125. In these, you can just, if you're finding the difference in these two stations here, you would ignore the difference. This one right here was on our test, and I got to looking at that, and for some reason, I got to struggling with that. Is that 49 feet or is that 4,900 feet? Well, you quit making the decision and you do what the station says. This is 365 hundreds right here. So if you take 365 times 100, that equals 36,500 feet. That would translate into 36,500 feet. This here would translate into 31,600 feet. So again, just ignore it. Take 365, 365. It's good to know where this is coming from, because everything on the left is hundreds. This is 3,650 right here, or 36,500, and it's an even stake. I forgot what we call that, but it doesn't have any extra footage over here. If it did, we would just have to write it as 36,528 foot. So there, take 365, and if you don't put those zeros in, you're going to get the wrong answer. 365, 365 00 minus, there it is, 316, 31600 equals, I didn't annotate it, but it's 4,900 feet. That's how far it is from this station to this station. You could do it 100 foot at a time and you'd come up with 4,900s to get here. If you don't consider the zeros, you're going to come up with 49 feet, which I was struggling with. Why am I getting this? You have to put the zeros, but it's okay to ignore that plus sign. Number 10, if you measured an additional 37 feet from station 25 plus 63, what would your next station be? Okay, I'm at station 2563. I want to go put a station 37 feet further than this one. So take 63, add 37, is 100. So it would be 2600. Your next station, if you added 37 feet, if you wanted to go 37 feet further than this to put a, say, an underground culvert in, you would be at station 2600. That's where you'd want it. Okay, uh, here's the final note on this. We have extended the test till tomorrow evening, I think. So jump in there, go back through it, have the video going. I don't care if you can do that, and take that week 3 quiz, quiz number 2 again, and you will have been exposed to all the answers. Hopefully not hopefully, but we will be dealing with station numbers again, and the idea is we go along, this will begin to absorb. It's kind of like learning to read uh, when you're young. You know, you can't learn to read For Whom the Bell Tolls by Hemingway. That's not a good book to start with for understanding. So we're starting with some basics, and we're going to continue to add things and get a little bit more complicated. I will post this on in week 3, and I will identify it as uh, let's see, I don't want to go too far. Let me see what I'm going to call it, so it'll be simple when you see it. I'm going to call this thing Introduction to the Use of Staking. That's what the video will be called, and I'll slide it in that module right by that week, by your quiz assignment. So uh, you'll have to have seen it to, for me to tell you where it is when you hadn't seen it. Anyway, good luck, and we'll visit again soon.